In this video, we are going to look at patterns in graphing, and we're going to look at how patterns can be turned into a graph, a table, and an equation. So let's get started. In our first pattern, we have at step 0, we have one box. At step 1, we have 3. Then we have 5. What does the next pattern look like? It probably looks something like this. Probably have 6 boxes followed by 1 on top. I know this isn't a very good drawing. It's the best I can do. Next pattern probably has 4 rows of boxes and 1 on top. And then the next one probably has 5 rows of boxes, 5 pairs of boxes and 1 on top. So if I count the number of squares, it's 1, then 3. So let's see, 1, then 3, then 5, then, oops, that doesn't look like a 5 at all. Then 7, then 9, then 11. So number of squares. Step 0, we have 1, then 3, then 5, then 7, then 9, then 11 on step 5. So let's graph this. Remember, this is a table, and we can assume x, the steps are the x value, and the number of squares are a y value, because x's always go first, followed by y's. So if at step 0, what is that ordered pair? That ordered pair is, oh, it's really bright, too bright, is 0, 1. So 0, 1 is right up here, 0, 1. Our next point is point 1, 3, which is over here, 1, 1, 2, 3, up. There you go. Our next point is 2, 5. So 2, 5 is you go right 2, up 5. Our next step is 3 and 7. So 3 is 1, 2, 3, 7 up, 1, 2, 3, 4, 5, 6, 7. And our next step is 4 and 9. So 4, 1, 2, 3, 4. 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, I'm actually doing this kind of the dumb, slow person way, but I'll teach you how to do it the smarter way. We're going to draw a line that connects all these dots. There it is. Now, we do have to continue our line by, and if we draw a ruler, we can figure out that, or we will draw a straight line that cuts through the whole thing. So you're not just going to start right here and go to the right. You're going to go to the left as well. So this is what our graph looks like. This is a graph of our changing pattern. This is the table that represents our changing pattern. We are also going to figure out an equation that represents our changing pattern story. Okay, so what is the slope? Okay, so slope and y-intercept, I'm going to overload you with information right now. First things first, for slope, you write the letter M. And for the y-intercept, I want you to write the letter B. And this is going to be important later on. Slope is M, and y-intercept is always represented by B. Why? Well, some math person decided it a long time ago, and everyone agreed. Whenever we say M, we're referring to slope, and whenever we refer to B, we are talking about the y-intercept. What is the slope? The slope is also known as the rate of change. Actually, I'm going to do this in something other than red. So the slope is also known as the rate of change. So rate of change. If you're doing a distance or time graph, that would be like the speed. And how do you figure out the slope? You look for the change in y. And you divide it by the change, or put it over the change in x. You may also see it in some advanced math books referred to as delta y over delta x. And what does delta mean? Delta is just a Greek letter, which is a triangle, and it means change in. So the change in y over the change in x. So what is the change in y over the change in x? Let's take a look. We can look for the change in y over the change in x by looking at our graph, by looking at our table. So let's see which one do we want to do first. Let's try doing it from the table first, because I think that's the easiest. Our change in y on the table is, what is the difference between here and here? How is y changing? And from here to here, and is it constant? Well, the change in y from there to there is, it's going up 2 every time, so plus 2, positive 2. Change from here to here, it's always positive 2. What about the change in x? From here to here, from here to here, from here to here, it's always plus 1. So our change from y to x is, the change in y is 2, the change in x is 1, and it's always 2 over 1. So our slope, remember, if slope is change in y over change in x, that means our change in y is 2, or plus 2. Our change in x is plus 1. What is a more simplified way of writing 2 over 1? Just 2. So our slope, or our m, is 2. What is our y-intercept? Okay, first of all, what is a y-intercept? A y-intercept is where our line, technically, where our line touches the y-axis. And what is the y-axis? This is the y-axis, remember? So where does our line touch the y-axis? Our line touches the y-axis at this point right here. And what is that point? What is the value of y at that point? The value of y at that point is 1. You can also think of the y-intercept as the starting point in our graph. So where does it start? It doesn't start at 0. It actually starts at, 0 for the y. It actually starts at 1. So if, let's say this was a graph about distance and time. So if this was time and this was distance, at 0 minutes, where does this person start? They start like 1 meter away from their actual starting point in our story. So think of it, you can think of it that way. How can we find the y-intercept in our table? Well, it's actually even easier. Y-intercept in the table is, at the starting point when x is 0, what is y? It's right there. So our y-intercept is right there. It's y-intercept. And you know it's the y-intercept because when x is 0, what is y? It's 1. All right. So we now have our slope, our y-intercept. We can use our slope and our y-intercept to write an equation. So all equations of straight lines will be written in this form. It's y equals mx plus b. So the only parts you fill out are m and this plus b. What is m and what is b? Y equals and that x, those will stay the same, but the m and the plus b will be different, may be different. So let's write our actual equation. Y equals, that's a given. What is our m? What is our slope? Our slope is 2. So replace m with 2. And then we need to bring down the x. Now, what is b? b is 1. Oh, and it's positive 1, so instead of plus b, plus 1. And that's our equation. What does this even mean? This basically is a representation, this equation is a representation of the graph or of the table of our story. What we can do with this equation is we can actually use it to say, hey, because the x's represent the steps, right, which are the steps right here, and the y represents the number of boxes, you can use our equation to figure out how many boxes you can expect on like the 6th or 7th or 10th or 100th step. So let's do an experiment. Let's say you were to draw a 6th step. How many boxes do you think we would have? Well, this is going up by 2 each time, right? So we should assume that out of the 6th step, we have 13 boxes. Remember, the boxes, or the number of squares, refers to the y, and x is the is going to be the step. So let's say we were trying to figure out hey, how many boxes would there be at the 6th step? You can use this equation to figure it out. So x is the number of steps, so we're going to replace x with 6. That's the number of steps. So x gets replaced with 6. It needs to be multiplied by 2, and you add 1 to it. So y would equal 2 times the number of steps, which is 6, plus 1. 2 times 6 is 12. Add 1, that equals 13. So y equals 13. So what this is saying is at the 6th step, we should have 13 boxes. Let's see if that's true. Let's see, at 6th step, 13 boxes? Yeah, that is true. So we can use our equation to figure out all sorts of stuff, like how many, what if there are 121 boxes? What step are we on? Or at the 80th step, how many boxes might we have? All right, let's go to the next question. Is the pattern linear or nonlinear? Linear just means it's a straight line. Is this pattern a straight line? It is a straight line. It's not like a zigzag line. It's not a curve. It's not, doing anything crazy. It's just a straight line. All right, and finally, is the pattern ascending, descending, or horizontal? If we read our graph from left to right, would it be going upward or downward or just going straight across? This is going upward. It is ascending. All right, let's go ahead and try. I'm going to jump to, you can try this one on your own, but we're going to jump to this one. It starts off with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes, and then it looks like it's subtracting 2 every time. So the next step looks like this probably. I'm guessing the next step looks like that, and the next step probably has no boxes. So we start off with 10, and then 8 boxes, then 6 boxes, then 4 boxes, then 2 boxes, then 0 boxes. So at step 0, we have 10 boxes. Step 1, we have 8, then 6, then 4, then 2, then 0. Let's graph that first. Our first point is 0, 10. So this is our x and this is our y. 0 and 10 is 1, 2, 3, 4, 5, 6, 7, 8, 9. No, 10 I guess is actually up there. So it doesn't really fit on the graph, but that's okay. 1 is 8. So at 1, you go 1, 2, 3, 4, 5, 6, 7, 8. So like I said, this is actually the dumb person way of doing it. And at 2, we go to 6. At 2, 1, 2, you go up 6, 1, 2, 3, 4, 5, 6. There is a better way to do this, which is by using our pattern. If we can figure out that our pattern for y's is to 10 to 8, is to go down by, not by 8, but it goes down by 2 every time. And our pattern by x is like to add 1 every time. If we know that is our pattern, we could follow that pattern to figure out the next point. So if we start right here, and our pattern is to go down by 2, y goes down by 2, x goes over by 1, we know the next point goes there. Oops, not by blue, not by red. And then we again go down 2 over 1, then down 2 over 1. And we could use this information to predict where the next one goes. You go down 2 over 1, down 2 over 1, down 2 over 1. And draw a straight line through all these points. All right, so we now have our graph. What is our slope? Remember, our slope is our m. And it's the change in y over the change in x. What is our change in y? We did the table before, so our change in y is -2, our change in x is +1. Let's use this graph to figure out our change. So what I'm going to do is I'm going to take 2 points that are touching like the corners, touching the whole number. So let's go with this point over here and this point over there. And what I'm going to do is I'm going to ask, what is the change in y? So how do I get from here to here? Well, I need to go down 2. So I need to go 1, 2, down 2, and that's my change in y. And I have to move over 1. So that is a change of +1. So that's how you figure out the slope. The change in y is -2. The change in x is +1. What is -2 divided by +1, or -2/1? That's just -2. What is my y-intercept? That is where my line touches the y-axis. Well, it touches it at 10. I know we can't see it there, but we definitely can see it right over here. So this is our y-intercept. At step 0, at the very beginning, our y-intercept is 10. +10. All right, and that is b. b equals 10. So y equals mx plus b. So we stick with the y, the equals. M is -2, right? It's not just 2, but -2. X is going to be x, and then b is 10, +10, so we write +10. And that's our equation. Is a pattern linear or nonlinear? It is a straight line, so it is linear. Is it ascending, descending, or horizontal? Well, if I read it from left to right, it starts up here and it goes downward, so we would say that is a descending pattern. So, something you may have noticed is that first pattern was ascending, and it had a positive slope of 2. 2 is positive, and the graph was ascending. Our next one had a slope of -2, and notice what we were doing with this one. It was descending. So that's something you should know. That's nifty to know. Positive slope means it's ascending. Negative slope means it's descending or going down. All right, let's go ahead and try this one. We may get to this one. This one's actually, we will get to this one. It is kind of crazy. So let's look at this. We've got a pattern of, let's see, it looks like 6, 2, 6, 2. I'm guessing the next one is a 6. The next one is a 2. So 6, 2, 6, 2, 6, 2. And it'll probably be another 6 and a 2. So at step 0, we're at 6. At step 1, we're at 2. And this is 6 again, and 2 again, and 6 again, and 2 again. How do I graph this? 0, 6. Well, 1, 2, 3, 4, 5, 6. Then 1, 2. 1, 2. The next one is 6, and then 2, and 6, and 2. How do I draw the line? Well, I go from this point to that point to this point to that point to this point to that point. Where do you think the next point would be? If you were thinking it's up here, you are correct. It would just go like that, and then down. Whoops. And then down, then up again, oops, and then up, and down, and up. So basically like that, like that, like that, like that. And it would even continue backwards. So technically, it would keep going this way forever. Oops, messed that up. Oops, darn it. Let's try that again, right there, and right there, I think, and then right there, and then right there. All right, so we've got this wacky pattern. Can I determine a slope? Well, if I try to look at this, I can't. I have a slope, but it seems to keep changing. If I look at my table, the pattern is the y goes down 4, but then the y goes up 4, and then it goes down 4. And with my x's, it's +1 every time. So can I determine a slope? Not really. Why not? Line isn't straight. So if line isn't straight, it'll be really hard to determine a slope. What is the y-intercept? Do I have a y-intercept? I do. Remember, it's a starting point, which is right over here as well. When x is 0, y is 6. Show the y-intercept on the table, graph, and rule. Well, I've already done that. Is the pattern linear or nonlinear? It is nonlinear, because nonlinear means it's a straight line. Even though these lines seem super straight, they're like, it's a bent line. It's like jagged. So it's not considered linear. Is it ascending, descending, or horizontal? Technically, it's ascending at some parts, and it is descending at some parts. You could say it's neither, or you could say it's kind of doing both ascending and descending, which is a problem. Let's go to the next one. In this one, we do not have any box patterns. We just have number patterns. So x seems to be just increasing by 1 every time. Y, on the other hand, is 2 to 5, 5 to 8. I think it is increasing by 3 every time. So we can assume that this increases by 3 as well, which should get us 14. And afterward, 17, then 20, then 23, then 26, I believe. All right. So let's write some points on our table. I'm just going to choose 3 points. My first set of points, 0, 2, 1, 5, 2, 8, and 3, 11. Why not? 0, 2, 1, 5, 2, 8, 3, 11. So 0, 2 is right there. If you noticed, the pattern is y goes up by 3, and then x moves up by 1, so up 3 over 1. And you can use that and extend it backwards. So like down 3 and backwards 1 will let me know where the point is in reverse. So let's do this, 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 and then that's what our line looks like. Our slope, as we determined, is the change in y is plus 3. So slope, that's plus 3 every time. And that's plus 1 every time. So our slope is, our m, is change over y over change in x, 3 over 1, which is just 3. Our y-intercept is where is our starting point. Our starting point is right over here, or right over there. And so the y value is 2 right there. So b equals 2. Let's use the slope and y-intercept to write the equation. Remember, y equals mx plus b. Our m is 3. Our b is 2. So y equals 3x plus 2. Use the equation to find the value of y when x is 100. So we're going to use this equation and figure out what y would equal when x is 100. So I'm going to have my equation, y equals 3. Now in place of x, I'm going to use 10 because they say when x is 10, place that with 10, plus 2. So what's 3 times 10? Well, that's 30, plus 2, that's 32. So that is going to be 32. Use the equation to find the value of y when x is 100. So y equals 3, and in place of 10, you're going to use 100, or x, you're going to use 100. 3 times 100 is 300, plus 2 is 302. And I think you could figure out what it would be if x were 1,000. So 3, replace x with 1,000. Add 2 afterward, you'd have 3,002. Would this be a linear pattern? It is linear. It's a straight line, right? And is it ascending, descending, or or horizontal? Well, if we read it from left to right, we start here, and it is going upward. So it is ascending. Let's take a look at the next one. This pattern, we go, x seems to be increasing by 1 every time. And y seems to be nothing. That's just a change of 0. So I should assume that this is still 6, and this is 6, and this is 6, and this is 6. So let's choose a couple points, like this one, this one, this one, and this one. 0, 6, 1, 6, 2, 6, 3, 6. So 0, 6 is 1, 2, 3, 4, 5, 6. It's right there. 1, 6, 2, 6, 3, 6, 4, 6. You can even go backwards. Basically, we have a straight horizontal line. What is our slope? Well, our slope is change in y over change in x. How much is y changing every time? Y changes 0 every time. Our change in x is plus 1 every time. So what is our slope? We can say it's 0 over 1, or most simplified is 0. So m equals 0. Our y-intercept is the starting point, which is right over here or right over there. And that value is 6. Let's let's write y equals mx plus b. Oops. Y equals mx plus b. Our y equals, our slope is 0, x plus b, which is 6. Almost looks like a b itself. Now, we could simplify this even further because 0x could be simplified. What is 0x? Well, it's 0. And would it make sense to write y equals 0 plus 6, or can we simplify that further? No, we can simplify that further. We can basically ignore the 0x and just write y equals 6. And that is our equation. So if we use our equation to find the value of y when x equals 10, well, when x equals 10, there is no x, therefore y is just 6. So when x is 100, it's 6, and when x is 1,000, y is still 6, because x does not affect anything on this at all, because it has a slope of 0. Is the pattern linear or non-linear? It's still a straight line, so it's still linear. Is it ascending, descending, or horizontal? It is a straight horizontal line. So that, and I believe that covers it. Actually, let's do one more. Wait a minute. Well, we'll get to it later, actually. We'll stop here. So go ahead and try some questions on your own. Good luck.